Okay, I'm going to talk about differentiation, but we're also going to move on to some shortcuts to make this faster. Okay, before we can do derivatives of polynomial functions, we need to discuss powers of x plus h because we have to plug those in. So I've already set up x plus h squared. That's going to be x plus h times x plus h. So the FOIL method, you multiply the first terms, x squared. Outer terms, h times x. Inner terms, h times x again. Last terms, h squared. And these combine into x squared plus 2hx plus h squared. Okay? X plus h cubed would be x plus h squared times another x plus h. That seems reasonable, right? So I'll take this, x squared plus 2hx plus h squared times another x plus h. I will take this times the first term, middle term, last term. So I'll get x squared times x plus h plus 2hx times x plus h plus h squared times x plus h. Okay? So distribute, distribute, distribute. And we have x cubed plus hx squared plus 2h times x squared plus 2h squared times the x plus h squared x plus h cubed. Okay? Now we're going to distribute these. So we have x cubed plus 3hx squared plus 3h squared x plus h cubed. Okay? At this point, I'm going to find a darker marker. An example 1 that goes f of x equals x squared plus 91x plus 104. Okay, I'm going to go straight to differentiation. So first, f of x plus h would equal x plus h squared plus 91 times x plus h plus 104. We just had this discussion regarding what x plus h squared is. So that's going to be x squared plus 2hx plus h squared plus 91x plus 91h plus 104. All right? Second, we subtract the original f of x. So minus x squared plus 91x plus 104. Now, folks, we're going to be subtracting something from itself. So these x squareds are going to cancel. Okay? We're going to be subtracting 91x from itself as well, and 104 from itself. And the only surviving terms will have h's in them. 2hx plus h squared plus 91h. Okay? Third, f of x plus h minus f of x over h is equivalent to 2hx plus h squared plus 91h all over h. Okay? And the h's are either going to cancel or go down a power. So this h will cancel entirely, leaving me 2x. H squared will become h to the first. This will become, these h will cancel, leave me 91. So fourth, and not before, h equals 0. So I have 2x plus 0 plus 91. Well, folks, that's just 2x equals 91, or 2x plus 91. So the derivative of this is f prime of x equals 2x plus 91. Okay? Example 2, f of x equals x cubed minus 106. Well, first, f of x plus h equals x plus h cubed minus 106. And we recently had this discussion over what x plus h cubed is. So I will go ahead and write down x cubed plus 3hx squared plus 3h squared x plus h cubed minus 106. Second, we will subtract the original f of x. So minus x cubed minus 106. Okay? So as a consequence, this x cubed is getting subtracted from this x cubed. This minus 106 is being subtracted from that minus 106. Okay? And the end result is these three move on down. 3hx squared plus 3h squared x plus h cubed. Third, f of x plus h minus f of x over h is these three terms all over h, and they will go down a power. So they will become 3, they'll go down a power of h. So this will become 3x squared plus 3hx, because that'll go down to h to the first, and then h squared. Fourth, h equals 0. So I will have 3x squared plus 3 times 0 times x plus 0 squared. Well, that's 3x squared. That's 0. That's 0. So I'm left with 3x squared. So the derivative of this function is 3x squared. Okay. Now, all of this can be shortened with some rules. Shortcuts. Rules. Number 1, we're assuming variable x. Okay, we're assuming a variable is x. Okay? If the function was in terms of another variable, we'd follow these rules for the other variable. So x to some power n would become nx, and you'd go down a power. Okay? Number 2, if you just had some number times x, would leave you just that number. And number 3, the derivative of a constant is 0. So for example 1, okay? Example 1, f of x equals x squared plus 91x plus 104. Its derivative, f prime of x, would be, you move the 2 out to the front, and you'll have 2x to the 2 minus first power. Plus, this is a number times x, so according to this rule, this would be just, this would just leave you the number. And the derivative of the constant 104 is 0. 104 has no variable, so it's a constant. So the derivative is 2x to the first plus 91. And in more simple terms, f prime of x, the derivative is 2x plus 91. Much shorter than what we had to do longhand. Okay? Example 2. We're going to use the example that we used up here, which is f of x equals x cubed minus 106. Its derivative, f prime of x, would be, move the 3 to the, according to rule number 1, move the 3 to the front, and we will go down a power. The derivative of my constant is 0. Okay? So f prime of x, the derivative, is just 3x squared, which is the same thing we got longhand, okay, using the limit definition. Now what I'm going to do next is I'm going to erase this part and move these rules over here and do more examples. Okay, I have put the rules over here. We're still assuming a variable of x, okay? But the rule, the differentiation shortcuts that we just discussed are going to be here. I also tacked on 2 more. X to some power differentiates as the original power times x to a lower power, 1 unit lower. A number times x differentiates as just a number. Derivative of the constant differentiates as 0. Okay? These two I'm going to save for later, but the derivative of the natural log is just 1 over x, and e to the x is its own derivative. Okay, so for example, I'm going to, the first few examples that I cover next are going to involve just these 3 rules. Okay? So let's say f of x is x to the 10th plus 5x to the 8th plus x squared minus 31x plus 283. Okay? Well, the derivative, f prime of x, will equal, okay, let me put some space between those so it's clearer on video. The derivative, f prime of x, will equal, according to this rule, per this rule, you're going to move the 10 to the front, and you will subtract the power from the, you will take this down a power. Plus 5, 8 will go to the front. You will have x to the 8 minus first power. The derivative of x squared, you're going to move the 2 to the front. The power of x will go down 1. Minus, this is just the constant times x. So according to this rule, the derivative of minus 31x is just minus 31. And then the derivative of my constant is 0. Okay? So f prime of x, simplify, will be 10x to the 9th. Okay? 5 times 8 is 40. You will go down a power to 7. This is going to be 2x to the 1st minus 31. Plus 0 doesn't factor into this anymore. So f prime of x is simply 10x to the 9th plus 40x to the 7th plus 2x minus 31. Okay? So I want you guys to get used to another idea. X squared is equivalent to 2x. X squared differentiates as 2x. All right, example 4. Let's say I have f of x equals x to the, let's make it that's fine. 31x to the 6th plus 19, or how about 22, x to the 4th plus 45x squared plus 90x, no, not 90x, okay, 93x plus or minus 107. Okay, so derivative. F prime of x will be, what we're going to do is we're going to skip the subtraction step for positive powers. So I'm going to have 31, the 6 will go to the front, and I will have x to the 5th. It will go down a power. 6 down to 5. Plus 22 times 4, x cubed. These two follow this rule. Plus 45, and the derivative of x squared is 2x. All right? The derivative of a constant of a number times x, so 93x would just be 93, and the derivative of my constant is 0. Okay? So f prime of x is just 31 times 6 is 186, x to the 5th, plus 88, x to the 3rd, plus 90x, 45 times 2 is 90, plus 93. That is your derivative. Okay? Example 5, I want to start bringing in these rules. Okay? So let's say f of x is x to the 9th plus 87 natural log of x plus 72 e to the x minus 48x, and we'll differentiate that. Now, if you notice, there's no constant, so we will need this rule, this rule, this rule, this rule. So f prime of x will be 21. You'll move this 9, you'll have move the 9 out the front, and you'll go down a power to 8, plus 87, and the derivative of the natural log of x is 1 over x. The derivative of 72 e to the x is just 72 e to the x. And the derivative of minus 48 times x is just minus 48. Okay, so simplified, f prime of x will equal 182 x to the 8th plus 87 over x, because 87 times 1 is just 87, put it over the x, plus 72 e to the x minus 48. Okay? Example 6. Let's say f of t is t to the 5th plus 84 natural log of t. We make it minus 84 natural log of t. Minus 87. Well, now we're just going to follow the same rules for t. Okay? So to amplify that, I think I'm going to change this entirely. Okay, example 6, f of t is 19 t to the 5th minus 84 natural log of t plus 87t minus 93. Okay? Now, because t is the variable, we're going to follow these rules for t. Okay? We're going to apply these rules to t. So f prime of t will equal 19 times 5t, and we go down a power to 4, minus 84, the natural log of t, the The natural log of our variable differentiates as 1 over the variable. So 1 over t plus the derivative of a number times t. We'll just leave the number. And the derivative of our constant is 0. Okay? So f prime of t is just going to be 95 t to the 4th minus 84 over t plus 87. Let me write this a little bit more clearly. Okay. What if we're using a different variable for x? So let's say g of x equals 22 x to the 7th minus 55 e to the x. Well, g prime of x would equal 22 times 7x to the 6th minus, well, the derivative of e to the x is e to the x, so this will just be 55 e to the x. So the derivative, g prime of x, is 22 times 7 is 154, x to the 6th minus 55 e to the x. Okay. Now, what I'm going to do now is I'm going to clear the board of these examples, and then we're going up in difficulty level. All right, to follow these rules well, sometimes they have to be rewritten to look like polynomials. Okay? Look like, not be polynomials. Okay? So this one would be rewritten using negative exponents. So 15x to 12th would be unaffected, but I would replace this with 17x to the negative 12th. Okay? This would be replaced with negative 33x to the negative 1st. This would stay the same, and this would stay the same. So 86x plus 231. Okay. Now, having rewritten this using negative exponents, I will now follow these rules. Okay? So f prime of x is going to be 15, and the 12 will go to the front, and I will go down a power to 11. Plus 17, the negative 12 would go to the front, and the power of x would go down 1 to negative 13. Be careful about that. That's not negative 11. Negative 12 would go down to negative 13. Similarly, I would have negative 33. The negative 1 would move to the front, and I would have x to the negative 2nd. Okay, the derivative of 86x is just 86. The derivative of my constant is 0. I'm not even going to bother to write it down. Okay? So, this will become 180 x to the 11th. This is going to be a plus times a minus is a minus. That's 204 x to the negative 13th. Minus times a minus is a plus, so 33x to the negative 2nd plus 86. All right? Or some instructors or homework or test quizzes, etc., might require this type of notation. Okay? So I converted my negative exponent. Well, shoot, this doesn't convert. Okay? Some of them might require your negative exponents to be made into fractions. Okay? Not always, but sometimes. Okay, example 9. Let's say f of x is 14 times the square root of x plus 33 times the cube root of x plus 6 times the 9th root of x to the 4th plus 70 times the 10th root of x cubed. So here it goes, okay? First of all, I'm going to rewrite this as f of x equals 14x to the 1/2 power plus 33x to the 1/3 power plus 6x to the 4/9 power plus 70x to the 3/10 power. Okay, and I'm still going to follow this rule right here. Okay, so this is going to be 14, the 1/2 will go to the front, and we will go down a power. Okay, plus 33, the 1/3 will go to the front, and we will go down a power. Plus 6, the 4/9 will go to the front, we will go down a power. Plus 70 over, and then you got to take 3/10 to the front. You will go down a power as well. All powers of x will go down one whole unit. Now, most scientific calculators would be able to do that for you. But I don't have a scientific calculator, and I'm going to pretend that you don't either. Okay? So 14, you're going to take the numerator times the whole number. Numerator times whole number, put it over the denominator. That's the simplest way to think of this. This is going to be 1/2 minus 2/2. You want a common denominator. So 1/2, 2/2. In this case, we have 33 times 1. 33 times 1 is 33. Put it over the 3. Here we did 1/2 minus 2/2. Here we'll do 1/3 minus 3/3. Okay. Oops. What I'm going to do is I'm going to go back, make these bigger. Okay. So this is going to be 14 times 1 is 14. Put it over the 2. X to the 1/2 minus 2/2 plus 33 times 1 is 33. Put it over the 3, and we have x to the 1/3 minus 3/3. Okay? Plus 6 times 4 is 24. Put over 9, and we have x to the 4/9 minus, we want a fraction of equivalent to 1. Based on 9, so 9/9. Plus 70 times 3 is 210. Put it over the 10. And we have x to 3/10 minus 10/10. Okay? Now, 14 divided by 2 is 7. 1/2 minus 2/2 is negative 1/2. 33 divided by 3 is 11. 1 take away 3 is negative 2. Put it over 3. Okay? These reduce. Common bottom are divisible by 3. 8 over 3. Plus 8/3. X to the 4 take away 9 is negative 5. Put it over 9. Okay? Plus 210 divided by 10 is just simply 21. X is 3 minus 10 is negative 7. Put over 10. Okay. Now, if you're required to put these back into radical and fraction and radical notation with fractions, then here's what you're going to need to do. First of all, they all have negative exponents, so they're all denominators. Okay, and I'll do the rest of them later. So this will be 7 over x to the positive 1/2 would be equivalent to square root, plus 11 over the cube root of x, and the other power will be 2, plus, and over 3, it's going to be the 9th root of x to the 5th, plus 21 over the 10th root of x to the 7th. All right. Again, not all textbooks, not all instructors, not all quizzes, tests, homework instructions will necessarily require that step. But I wanted to show it in case it was necessary. And that's it. This is where I stop. Good luck.